So as we get it started here with our part 3 predictions based on climate indicators, we do need a calculator. So make sure you have one handy either on your desk or split screen, something like this, so you can use it as you go. So we saw in our previous sections that obviously there's things happening in the earth around us, and changing carbon emissions, like we saw in part 1, changing carbon emissions even drastically still means long-term temperature change. So we want to see, well, what does this look like in the future here if we are seeing these kinds of trends happening right now? Well, how will that trend translate into a prediction both 20 and 100 years from now? So we've got our current graph right here. We want to use that to predict forward. So we need to grab some data. So my recommendation in class was to use the two most recent, or use some recent data. So I'm going to recommend that you use 2020 and the year 2000 for your data points. So that's, of course, right here on the graph and here on the graph. So what we have to do is then view the graph at these 2 points to figure out, well, what are those y values? So at the year 2000, I go straight up here, I'm going to notice my data point is pretty much right on the 25. So that's my 2000 data. And as far as 2020, I've got the line there already. The graph goes just about to that point. So I'm going to predict, say, 2020 is going to be maybe 37. Okay? So here's my data. So I have to then notice I've got my math in here. I've got to do a little subtraction and then divide them out. So I've got plus or minus, let's see, 37 minus 25, that's where I'm getting this info. So I got a change of 12 billion carbon emissions, and that's happening over a 20-year period. So every 20 years, according to my trend, I'm noticing that changes 12 billion carbon emissions, 12 billion tons. So I want to know, well, what's that per year? So I'm going to plug that into my calculator. 12 divided by 20. Oops. 12 divided by 20. So per year, I have a 0.6 billion ton increase per year. That's the important part I need to do. I need to find. I'm going to use that throughout my calculation. So I took 2 points on my graph. I took 2020 and 2022, and I looked at how much it changed in that 20-year span and used that change to calculate my per year change. So 0.6 of a billion tons per year. So I'm using that down here. So we're trying to predict to the year 2040. Well, that's 20 years from now, with that change of 0.6 per year. So I'm thinking about in 20 years' time, if it continues to change at 0.6 per year, well, what will that total increase be over that 20 years? So 20 years of that increase of 0.6 means by the year 2020, it will have gone up 12 billion tons from where we are now. So that 12 billion years, or 12 billion tons, I want to add that to my current 2020 value. So on the graph, we said 2020 was at 37 billion tons. So that means in 2040, my graph should read 12 plus 37, 49 billion tons in the year 2040. So if I know it's changing this much per year, well, over 20 years of that change, I have to increase 12 billion tons in that time frame. So 12 more billion years from where it's at in 2020 puts me on the graph at 49 billion tons. So I'm here on my graph, the year 2040. I want it to be up to, what did I say? 49. So I wanted to point right here. So that's my projected graph to 2040. I want to do the same thing for 2021. What's it going to look like in this time frame if it continues in that same increase? So again, my rate of change is what I calculated, that 0.6 per year. Well, this is 100 years from now. So I need that 0.6 times 100 is what I'm thinking about. So I've got 100 years of changing 0.6 per year. 100 times 0.6, looking at a change of 60. So again, going up 60 billion tons from what it was at in 2020, 37. I'm going to see it on the graph be a total of 97 billion tons. Oops, this should say 2120. That's a typo. Okay, so at 2120, I want it to be at 97. Now it's going to be off the chart right here. So again, there's my prediction if I keep trending in the same way that we've been trending during 2000 to 2020. If this trend continues, here's where that data will end up for 2021. So the question here is, well, what will that do to us? If our prediction is correct, what kinds of changes might we see on the world because of that ginormous increase in carbon emissions? So make two predictions here. What are we going to see on Earth if carbon emissions continues in that same trend? And you're doing the same thing here. So my recommendation again to you to get started is start with that 2020 and the year 2000. Use those points on the graph. Read the data there. Plug those in. And figure out your rate of change for 20 years' time. Well, what does that mean per year? Plug it in just like we did. If it's changing that much for 20 years, times 20. Changing that much times 100, and add it to the graph. So you're going to get your projection with your data points out here.